Hello, AP Calculus students of the future. It's Mr. Ford with another summer packet tutorial. Today we're looking at topic K. I think we gotta be close to getting halfway through, probably a little further than half through this summer packet. Today we're looking at complex fractions, and we're just going to jump right into this one because by doing the problems themselves, we will quickly come across all the lessons that we need to learn about how to handle these kind of problems. Again, the topics that we're covering here in the summer packet are all kind of like things that, again, I've talked many times. I don't want to use the word should so much because it's got kind of a punishment notation. But these are things that you want to be aware of while you're getting ready for the class. There's just things that you will come across. They're not calculus topics per se. They're just like things that come up in calculus. So let's talk about number one, 5/8 over negative 2/3. Well, there's a lot of important reasons that we talk about in like middle school education when I was teaching middle school back in the day about why this works. But the best way to handle a problem like this is to flip the bottom fraction and multiply. So I'm flipping negative 2/3 and making it negative 3 over 2. And so this gives us negative 15 over 16, and that's all I have to say about this problem. With number two, you want to get pretty good at dealing with addition of whole numbers and fractions. It's a topic that comes up all the time, especially with some of the algorithms we run in calc. So being aware of how to make this happen is a good thing as soon as you possibly can. Now, you can, in this problem, I'll show you kind of two different ways to handle this. You could take the 4 from this problem, and you could rewrite it as 36 over 9, since that is the same fraction. And that gives you 34 over 9. And you could do the same thing down here. You could rewrite the 3 as 9 over 3, plus 4 over 3, since 9/3 is 3. And that would give you 13 over 3. And then you can do the same thing you did in the last problem. But we're going to start using a really common strategy where we multiply everything by a common denominator, or least common multiple. If you're looking at 9 and 3, which are the denominators in this problem, the least common multiple of those numbers is 9. So let's multiply everything by 9. We're going to multiply by 9 over 9. We have to multiply by 9 over 9 because then we're multiplying by 1, and then it's allowed to happen. And what's going to happen here is we have to kind of distribute. And you'll see pretty quick that this answer gives us the same thing as the answer up above, but it does save us a couple steps down the line. So 4 times 9 is 36, and then the 9s cancel out with 2 9ths, and you get 36 minus 2. On the bottom, 3 times 9 is 27, and the 9 doesn't necessarily cancel out with the 3. It divides into 3, and 3 times 4 is 12, plus 12 down below. And so what we get here is 34 over 39. Or sorry, 34. I wrote 43. A little bit of the dyslexia came in to haunt me there. So this is a faster method than doing it the other way, which would involve dividing those two numbers and then flipping and multiplying, but you'll get the same answer no matter what. Let's try that with number 3. Number 3, the best way to handle this is just to multiply everything by a least common multiple. So we have 2, we have 5, and we have 4. The least common multiple of those numbers, least common multiple of 2, 5, and 4. Let's see, 10, no. I think 20 is the number I think of. Yeah, let's say 20. It's worth mentioning that any common multiple works. It's just that you look for the least one because it's the smallest one and the easiest to work with. So remember that we are distributing this all throughout the top and the bottom of the fraction. 20 times 2, 40. 20 times 7 over 2 becomes 7 times 10, since 20 divided by 2 is 10. That's 70. And then same thing, 20 divided by 5 is 4, and 4 times 3 is 12. On the bottom, 20 times 5 is 100, and 20 times 3/4, well, 20 divided by 4 is 5, and 5 times 3 is 15. And now all we got to do is add it all up. It's going to be 110 plus 12, 122 on top, 75 on bottom. I'm going to go ahead and assume that they don't, 85, whoops. I'm going to assume they don't have any thing in common. I have my calculator cam set up right here. Here's my calculator, and there it goes to the magical camera down below. But I think the philosophy of the summer packet is how much can we do without a calculator? Because there is a specific topic later on about calculator stuff, but a lot of AP Calc you're not actually allowed to use the calculator on at all, both on the AP test, because the AP test says so, and also because you don't need one. The nice thing about calculus is once you learn it, you realize that a lot of the stuff that you had been using a calculator for in Algebra 2 or pre-calc, you don't need a calculator anymore. Anyway, number 4. Okay, now we got x's involved. Things are going to be a little more abstract, but we're going to use the same trick here. Least common multiple of x and x is, of course, x, so we're going to multiply everything by x over x. This is going to give us x squared minus 1 over x squared plus 1. And I don't believe we can do anything with this. I'm tempted to factor the x squared minus 1 into x plus 1 and x minus 1, but I don't think the bottom will factor into anything, so it wouldn't be worth it. Number 5, now here's where we get a little tricky. Negative exponents. It might be worth taking a minute to rewrite this with fractions first so we can start thinking about least common multiple. X to the negative first power, for example, is 1 over x. And on the bottom, x to the negative second power is 1 over x squared. So right away we can replace the x to the negative first and x to the negative second with those respective pieces. And now your least common multiple is just x on its own. Or no, would you need the x squared? You would need the x squared. I'm thinking greatest common factor. Least common multiple, you got to have everything. So x squared over x squared we're going to multiply by. This is going to give us x squared plus x on top and x squared minus 1 on the bottom. And again, I'm tempted, I think we can factor a little bit and simplify it. Because on the top, you can factor an x out and get x plus 1. And on the bottom, you can factor into x minus 1 times x plus 1. And then now the x plus 1 cancels out, and you finally get x over x minus 1. That's my simplest possible answer for this question right there. Question 6, we're going to do kind of the same thing. Let's start by just making all these fractions 1 over x plus 1 over y over x plus y. Now, the only denominators that we have to worry about here are the x and the y. So the common multiple that we're looking for is xy. That's the number that contains both x and y as factors. So xy over xy is going to have to happen there to make this happen. So let's make that happen in a step down below. When we multiply, we're distributing here. When we multiply xy times 1 over x, the x's will cancel out, leaving just the y. So the top of the fraction is going to be y plus. And when we multiply xy times 1 over y, the y will cancel out, leaving just the x. So we have y plus x on top. On the bottom, we're going to have, well, again, we have to distribute. Xy times x is x squared y, and xy times y is xy squared. I don't think there's anything we can factor out of this. I certainly don't think we can factor out an x plus y, or can we? We can. Yeah, let's factor out. Let's see. Let's leave the top alone. X plus 1. I'm gonna rearrange it so it's alphabetical order because I'm a little bit nitpicky sometimes about that. As far as the bottom goes, the common factor is xy. Actually, maybe we should not have multiplied it. We should have left it in its base form. Xy times x plus y. We should have just used this version of it. That's exactly the same thing. We kind of went into the multiplied version and then back to the factored version. But the x plus y is now cancel out. So 1 over xy. Looking for there. It's always kind of weird when you see a problem like this where the finished answer looks very simple compared to the original problem. We see that a lot. Okay, looks like we have 3 more of these to do. Yes. Okay, they're going to start getting a little bit hairy on these ones, but we're going to keep using the exact same strategy, so we're not going to get panicky. It's going to be the same thing. So let's start with number 7. We're going to have 1 over x squared plus 1 over x plus 1. And on the bottom, we have 1 over x squared minus x. So again, we're going to focus our attention on the denominators that we see in this problem. And the least common multiple of all 3 of those is x squared. We're going to multiply everything by x squared over x squared. And remember, there is a distributive property happening because there's kind of an invisible parentheses around both the top and the bottom. The top, the x squared will cancel out in the first term, so it's just 1. X squared divided by x in the middle term will just be x. And x squared times 1 is x squared. I don't think that factors. I don't think it does. I might stop and look at it for a little bit longer, but it doesn't. On the bottom, x squared times 1 over x squared is just 1, and we have minus x to the third. Now that can be factored. This is a difference of cubes down below. So maybe that's worth remembering how that works. Difference of cubes, I think I mentioned back in the factoring video. I think it was topic C or D. I think I remembered mentioning that I never memorized the difference of cubes. But it's worth taking a minute to look at this. If you want to skip ahead 30 seconds in this video, I'm going to go make sure I have the correct one written down here. Let's see, difference of cubes. I mean, to be honest, the difference of cubes shows up in a lot of exercises we do in class, but it does not show up on the AP test a whole lot often, so, but it does from time to time. So difference of cubes looks like this: a to the third minus b to the third, which is what we have, is going to be a minus b times a plus ab plus b squared. That's what we're looking for in this problem. Oops, let me get my face out of the way. There you go. So let's think about that for a moment. We're looking at a minus b. In this case, our a is 1, and our b is x. Those are the things that are being cubed. So leaving the top of this fraction alone, the bottom, we're going to start with 1 minus x, and then we have 1 squared plus 1 times x plus x squared. And look at that. That factor actually cancels out of the top and the bottom. And so this actually simplifies this way down to just be 1 over 1 minus x. Pretty neat the way that works. Let's take a look at number 8 for a moment. Okay, this one's got a couple fraction things going on here. You know, I'm tempted with the, I'm tempted to just handle 1/3 and 3/4 right now and just kind of keep them as a common multiplier out front, but maybe not. Negative 3/4 power. Ooh, that's going to be interesting. Pum pum pum. Pum 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 pum. Pum 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 pum. Well, you know, I'm just thinking about this thing in chunks. This yellow chunk, for example, off the top of my head, that could be rewritten as 1 over 3x minus 4 to the 3/4 power. But, you know, that doesn't really help us isolate anything. We can't really do anything with that. So I could move it to the bottom of the fraction, but I think we'd have the same setup. So let's instead focus our attention on the fractions, 1/3 and 3/4. Let's try the same process we've been doing. I mean, the least common multiple of 3 and 4 is 12. So let's just multiply by 12 over 12 right now. We'll deal with 3x minus 4 to the negative 3/4 later. So what that will do on the top of the fraction, 12 divided by 3 is 4. So we're going to have 4 times 3x minus 4 to the negative 3/4 power. And on the bottom, we have 12 divided by 4 is 3, and negative 3 times 3 is negative 9. So this is negative 9 down below. And I don't really think there's much more we can do with this other than take this entire chunk of the problem. Whoops, whoopsie, 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 whoopsie. We can take this entire yellow chunk of the problem and move it all to the bottom of the fraction and deal with this negative exponent that's right there. So we are going to have 4 on top. I believe that it's the only thing that we're going to have on the top of the fraction. Negative 9 will be out in front, and we'll have 3x minus 4 to the positive 3/4 power. I don't think we can do anything else with this. I mean, the 1/4 power, 3 and 4 will not be perfect fourth roots, and you get raised into the third power, but I don't think that would make it any more or less complicated. That's it. I like that answer. And number 9, we'll do one more of these. Again, right away we got a bunch of things that we can move to the bottom of fractions right now. Oh, it's Be Real time. Are you guys on Be Real? Hang on, I'm going to stop this video. Or I'm going to just take a minute to take a picture of myself recording something really quick. Hang on. Oh, there's all my math right there. That'll be good. Cool. Be Real is the cool social media of the future. All right, here we go. We're going to dive right in. The first thing we should do is we should move anything that we can to the bottom of a fraction so that we can think about what we're going to multiply by in order to cancel these things out. The first term, which I'm going to highlight in yellow and refer to as the yellow term, really we can't do anything with this, so we're going to leave it alone. The second term, though, which I'm going to refer to hereafter as the green term, we can take that negative 1/2 power and move to the bottom of a fraction, which we will now do. We'll leave 2x squared on top. We will put 2x minus 1 to the 1/2 power on the bottom, and we will leave 2x minus 1 down there. Now that means that if we're talking about working with fractions in this problem set, we want to identify the denominators that we're trying to cancel out. We're trying to get it all to be just like one line on top and one line on bottom that we can then easily work with. Right now, the fact there's a fraction within a fraction, unacceptable. So we're going to cancel it out. We're going to multiply everything by 2x minus 1 to the 1/2 power over 2x minus 1 to the 1/2 power. We do that because we have to keep it algebraically the same. So we're multiplying by 1, but 1 has taken this bizarre form that we've got here. Now, as far as working through this, let's be careful. Remember, this is basically a big distributive property on the top, but, you know, we have this yellow chunk times 2x minus 1 to the 1/2. And that's actually really easy to deal with, because what's going to happen here is 2x minus 1 to the 1/2 times 2x minus 1 to the 1/2. We're actually just going to add those exponents together, and 1/2 plus 1/2 is 1. So we're going to have 2x times 2x minus 1. And that's it. And, you know, it might be worth just writing to the first power here to drive home the idea that 1/2 plus 1/2 is 1, and that's what we did to get it there. It's pretty slick. As far as the next term goes, the what we called the green term in the last step, the green term just cancels out. 2x minus 1 to the 1/2 power just goes away. So it's just now minus 2x squared on the bottom. And that is times, or divided by 2x minus 1. Right there. The only thing left to do here, I think, is to factor out maybe a 2x on the top. Or maybe we should expand it. Should we expand everything out? Are we going to be able to factor out 2x minus 1 to any power? Well, let's play around with this a little bit. Let's just try a couple things. Let's start by distributing it. Let's just do the distribution here. We'll have 4x squared minus 2x squared. Oh, this will be good. Over 2x minus 1. Just doing the distribution with these two terms. Whoops. Again, my tablet cannot think as fast as I need it to think sometimes. Taking those and making them those right there. Next, we will combine like terms. We have 4x squared minus 2x squared, so that is 2x squared minus 2x over 2x minus 1. And look, we can factor out an x or a 2x. No, if I factor out a 2x, that must be 2x minus 1. Oh, did I miss? Oh, you know what? I missed something in the last couple steps. Sorry, I got to back up for a minute. Never addressed what these two multiply together is. Look at that. I never thought about that. Hang on a minute. Let's erase the bottoms here. So we have on the bottom of this fraction, we have 2x minus 1 times 2x minus 1 to the 1/2. So really the question we got to answer is, what is 1 plus 1/2? A simple question. We actually answer this question a lot in calculus. 3 over 2. So we have on the bottom of this fraction 2x minus 1 to the 3/2 power, which I should have had on the bottom for all of these steps, and I kind of forgot about it. Well, I was kind of hoping that we could get a 2x minus 1 on the top of this fraction so we can do some cool cancel-y do's out, but I don't think we're going to be able to. I think the best we can do at this point is actually just take this top fraction there, factor out a 2x, which will leave us with x minus 1, and 2x minus 1 to the 3/2. I think that's as best we can do. I think that is as simple as it's going to get in this problem. Whew. Pretty slick. This one came out less than 20 minutes. Look at that. We did it, guys. Hey. Okay, we're into topic K. Pretty groovy. We call these sometimes, just for a little bit of a wrap-up on this one, sometimes we have jokingly referred to these as fraction action problems. I had a teacher friend who used to call them those. Anytime you got a bunch of fractions, you just want to clear them out by multiplying by the least common multiple. Very cool. Okay, hope you enjoyed your mathematical vitamin of the day. Hopefully you're enjoying your summer. Maybe you're going to go to work right now. Maybe you're going to go play beach volleyball or do something fun in the sun. I hope you're enjoying yourself. I hope you're relaxing. Hope you're staying sharp. I can't wait to get back in the fall and work with you guys through the AP Calc course. It's going to be a lot of fun. It's going to be a great class, and I'll see you in the next video.